Hello again, and welcome to this tour of the June 15th issue of AJP-Heart and Circulatory Physiology, or From the Editor's Desk. This issue contains 3 great reviews, 13 original research papers, 1 editorial, and 1 letter to the editor. I hope you enjoy it. In a review by Willis, Ponce, Balbuena, and Jalife, the focus is on how the main inward sodium channel, NaV 1.5, and the inward rectifier potassium channel, KIR 2.1, function within macromolecular complexes to control cardiac excitability. A discussion of how they physically interact with each other and various structural proteins helps to understand the genetic and acquired basis of arrhythmogenesis. Alban et al. Studied the role of phospholipase C in myogenic tone of pressurized mesenteric arteries. Inhibition of PI phospholipase C did not affect depolarization-induced contraction, but modulated myogenic tone. Inhibition of arteries with an inhibitor of IP3 receptor-mediated calcium release did not affect myogenic tone. D609, an inhibitor of phospholipase C and sphingomyelin synthase, strongly inhibited myogenic tone and had no effect on depolarization-induced contraction. The results suggest that PI phospholipase C and PI3 are not required to maintain myogenic tone, but the diacylglycerol produced by phospholipase C and sphingomyelin synthase is likely to increase calcium entry and promote vasoconstriction. Aogi et al. Used transgenic mice overexpressing cardiac mTOR to evaluate its protective role in ischemia-reperfusion injury in the hearts of obese mice fed a high-fat diet. In a Langendorf perfused preparation, mTOR overexpression demonstrated better cardiac functional recovery and less necrotic markers. In vivo ischemia-reperfusion models, mTOR overexpression preserved cardiac function and prevented myocardial scarring. These findings suggest that cardiac mTOR overexpression is sufficient to prevent the detrimental effects of diet-induced obesity on the heart after ischemia-reperfusion injury by reducing cardiac dysfunction and myocardial scarring. Finally, Heilman et al. Sought to determine the role of phosphodiesterase 5 in the right ventricle and left ventricle in a hyperoxia-induced neonatal model of pulmonary hypertension and right ventricular hypertrophy. Hyperoxia-induced RVH in mice after 14 days, and the RVH did not resolve until 56 days. Hyperoxia-induced PDE5 expression and activity in right ventricle, but not in left ventricle. Sildenafil, a PDE5 inhibitor given during hyperoxia, prevented RVH, decreased RV PDE5 activity, and increased RV cyclic GMP levels. Mice with cardiac-specific overexpression of PDE5 had increased RVH in room air. These findings suggest that normal RV PDE5 function is disrupted by hyperoxia, and elevated PDE5 contributes to RVH and remodeling. Thank you again for joining me on this video trip through the June 15th table of contents. Have a good 2 weeks. See you again, and don't forget to send us your best work now.